All right, we are moving into section 1-2, still in chapter 1, the basics of geometry, and we are going to look at measuring segments and the segment addition postulate. So let's start off with something we need to understand the difference of, and that is congruent segments compared to equal segments. So whenever we're dealing with numbers, lengths, measurements, we are going to write that like this: AB equals CD. Now, what that says is that those two measurements have the same value. But when we are talking about those two segments as figures or shapes, we are going to refer to them as being congruent. Congruent is more than just equal. There is a part that is like an order matters. So like A goes to C as B goes to D, kind of a thing. So the order matters as much as the equivalence part. So understand there is a difference. Anytime we're talking about numbers, lengths, and measurements, that's our equals. And notice we don't put the line segment over the top. When we're talking about the figure or the shapes are the same, we're going to be talking congruence. Now, we have a postulate again. Remember, a postulate is a rule that we accept without having to prove. Okay, it is an understood kind of that duh kind of statement that, of course, that's true. Okay, so this is called the ruler postulate. The ruler postulate simply says the distance between points A and B, written AB, is the absolute value of the difference of the coordinates of A and B. Well, so over here we look and it says, here's my segment AB. So if I want to know what that distance is from A to B, then what I'm going to do is it will be the absolute value of A minus B. Now, brings us to a question then. Why does it need the absolute value part? And the answer comes back to this word right here. It is the distance. And the reason it has to be the absolute value part is included in this is because distance is always positive. Meaning, for example, if I were to go out to the track and I would walk a mile, well, and I asked you, how far did I walk? We would say a mile. But then if I turned around and I walked backwards for a mile and I said, how far did I walk? Just because I'm walking backwards doesn't do anything. Since I'm walking backwards, it's still a mile. So distance is always positive. So we do the absolute value part to guarantee that. Okay, so when I come over here and I say, okay, let's subtract, let's find the distance, the value between C and D. So if you look, I'm going to start off and I'm going to say, well, that would be -7 minus -2. Okay, so when I look at that, that's plus a positive, right? So -7 plus 2 gets me absolute value of -5, which is 5. Now, we can also counteract that by going right minus left. So if we go start at -2 and we subtract -7, it will give us the positive value right away. Okay, so either way you want to think about it, but just know that distance always has to be positive. So EC, so I'm going to start at E, I'm going to go 5 minus -7, absolute value of that. So 5 plus a positive, so that's the absolute value of 12, which is 12. DE, I have absolute value of 5 minus -2 plus a positive, so that's going to give me 5 plus 2 is 7, so the absolute value of 7 is 7. Okay, so that's how we find the distance between 2 points on a number line. Now let's talk about a second postulate that we have. A second postulate that we have is called the segment addition postulate. Simply put, what it says is hey, if we have this point B that is between A and C, then the segment AB plus the segment BC is equal to the full segment AC. Okay? So if also we can reverse it, if AB plus BC equals AC, then that tells us that B has to be in the middle. Okay? In other words, if we have a line segment and it's cut up into pieces, we can take those pieces and add them together, and it will give us the full measurement of the length. So let's try a couple of them. So if I start off, I'm going to go and I'm just going to put the values in of what I need. So I'm going to start off and I'm going to say, okay, RS is 12. So this measurement is 12. ST is 17. And I want to know what is RT. We know that to be X. So to do this problem, I'm simply going to take my two pieces, 12 plus 17, and that has to equal the value of X. So we add those together, and that gets me 29 units for the length of RT. Okay? So let's try another one now. So we come in here, we start off, it tells me RS is 11 this time. It tells me ST is X, but it says that RT is 31. Okay, so I go to my segment addition postulate again. I have the first piece of 11 added to X, and that has to equal 31. So now we solve this one-step equation, and I know that the value of ST has to be 20 units. Okay? Let's try another one. So now we're just going to put a little more algebra into it. So here we're going to start off, and RS we know is 3x. ST we know is 2x minus 6. And we know the full length is 24. Okay, so we set it up. We go 3x plus our value of 2x minus 6, and that has to equal 24. So now we would combine our like terms, and we get 5x minus 6 equals 24. We would add our 6 to both sides as we work to isolate the variable. We would then divide that by 5, and we would end up with x equals 6. Now, if I went and I said, okay, then what's the value of RS and ST? So to find RS, we would take the value of 6 and plug it in. So it said it was 3x, so it'd be 3 times 6, the value of x, which would be 18 units. ST then would be 2x minus 6, which is 2 times 6 minus 6, which 12 minus 6, that is the value of 6. Now, if you take 18 plus 6, did it equal the 24? That's an easy way to check your math to make sure that you are doing it correctly. Okay, let's try another one. So on this one, we start off and we say, okay, I have RS is 17, ST is 2x plus 5, and the whole thing is negative 2 times the quantity 3x minus 7. Okay, so we set that up. So we take 17 plus 2x plus 5 equals negative 2 times the quantity 3x minus 7. The two smaller pieces add up to the whole. Now we just work that out. We're going to combine some like terms over here. So we get 2x plus 22, and that equals a negative 6x plus 14. Now we're going to move some. So I'm going to move my 6x to the left. I'm going to do that by addition. Then I'm going to move my 22 to the right. And that would end up giving me 8x equals negative 8. I would divide that by 8, and x would equal a negative 1. Then we would take, if I then asked you, okay, great, what is the value of st? So we would go 2 times negative 1 plus 5, which would be the value of 3 units. And then to find RT, we could take the 3 plus the 17, which would tell me it better come out to be 20. Or I could plug in, so I go negative 2, 3 times negative 1 minus 7. So this becomes negative 2 times negative 10, which indeed comes out to be 20 units. So I know that I did that process right. And that is what we needed to know about measuring segments and also the segment addition postulate.